Howdy, howdy, this is Mr. Potter. What we're going to do today is we're going to go through the free response questions that were just released for the 2015 computer science exam. I'm sure I'm going to be making some mistakes along the way, so if I make some code mistakes, I'll be sure and put a comment in the video. If you put a comment down below, I would really appreciate any feedback you can give me on this. So let's go ahead and go through this. Problem 1 is a very straightforward problem. In problem 1, they asked us to write a static method that will take an array and total up the values. So in other words, I've got 1, 3, 2, 7, and 3, and when we add all those up, we should get 16. So we're going to have to go through this array and accumulate the values. So very straightforward, no problems with that. Let's go ahead and talk about how we would write this. So there's a couple of ways that we can do this, and I want to do it both ways just because I think it's important. So I'm definitely going to need some type of accumulator, which I'll call total, and I'll go ahead and set that to 0. And then I'm going to have to remember to return total when I'm done. So in between here, I need to make sure that I access all the elements of the array. So there's a couple of ways I can do that. The easiest way, the most straightforward way, is to set up a loop. So int I gets 0, I is less than array.length, I++, and just say that total gets total plus, and then whatever's in box I of our array. So that's our very straightforward array sum. We've probably written half a dozen methods like this in our class to go through and add stuff. And we're probably looking at 1 point for coming up with an accumulator variable and successfully returning it, and then 1 point for this loop here. But there's another way that we could write this, and so I'm going to talk about that. Again, I still need an accumulator variable, so int total gets 0 and return total. But I could use a for each loop in here. I could do for, and I could say int I in array, and then I could just say total plus gets I. And it does the exact same thing. It kind of does it the exact same way. It's just a little bit shorter code. And of course, we're probably still looking at the same 1 point for our accumulator variable and 1 point for successfully going through all the items in our loop. So very straightforward, very simple method we have to do. Nice start to our AP exam. So we'll go ahead and clean this up and move on to part B. So on part B, now we have a method called row sums that's going to add up each row in our two-dimensional array, and we're going to return these as an array of sums. And what's going to be very important is the fact that we have to use the method that we just wrote. Now we just wrote this array sum method down here. We're going to have to use that. So the idea here is that I should be able to go through each row of this array and add up the elements in order to determine it. So the first row is going to add up to 16, second row adds up to 32, third row adds up to 28, and so forth. So that's what we're doing in this next method. And what's really important is that it tells me that I must use array sum to receive full credit. So they don't want us reinventing the wheel. We can assume that our array sum works no matter what we wrote in the previous problem. So what I need to do here is, because I'm going to be returning an int array, I need to declare an int array. So I'm going to call this totals, and this is going to be a new int array, and I want the size to be equal to the rows that we had in our array2d. So this is going to be array2d dot length. So that's going to set up our totals, and then we're going to make sure we return totals when we're done with this. In the meantime, we're going to have to go through each row of our matrix, each row of our two-dimensional array, and total up those items. So in this case, I can't use a for each loop, and the reason is because I need to put something in a very specific box of the array that we just created. So I need to actually iterate through the array. I need to do a regular for loop. So int I gets 0, I is less than totals.size, dot length, and I++. And then what I'm going to do is I'm going to say total in box I is going to get, and remember I'm required to use array sum. So array sum for the row that we're looking at, which is array2d box I. Now I can't use an iterated loop. I have to use an iterated loop. I can't use a for each loop because although I could get the ith row, I wouldn't know which element of the matrix I could do. Technically I could say, int spot gets 0 and then use a for each loop. And here I would say int array row in R2D. And then here I would say totals subspot is going to get array sum for the row. And then I would have to say spot plus plus. I'd have to do that in the context of this for each loop. So I could use a for each loop here, but it adds a little bit more hardware because not only do we have the for each loop, but we also have to keep track of which spot we're going to put it in and keep accumulating it as necessary. And a regular iterated for loop, I think, does that much better. So this method here is probably the better one to use, and this one here is okay, but I think it's a lot more overhead just to force us to use a for each loop. Looking at the points on this, I'm guessing that we're going to have 1 point for declaring a value that we're going to return, declaring this array, making sure, of course, that it's the correct size. 1 point for making sure that we successfully call on the array sum, and then 1 point for making sure that we call all the array sums as needed. So 1 point probably for a successful call and a successful assignment, and 1 point for going through and actually putting it in. So 3 points probably for part B. And again, I would not do this for each loop, although you can do it. I really think it's more trouble than it's worth. Definitely in part A, the for each loop is going to help out, but in part B, not so much. So now we're going to scroll down to C. So the idea with C is that we want to know if a particular array is diverse. And an array is diverse if no two rows have the same elements. Notice here, none of these rows have the same elements, so we would say that this is a diverse matrix. But here, 2 of the rows have the same size, and so we would say this is not diverse. And so we're going to be keeping track of truth or falsehood in here. And we're going to have to go through each row, so we're going to be calling on the methods that we've written so far. So we need to make sure that we actually call on row sums in order to get this to work. So what we're going to need to do is we're going to need to go through and not only find all the row sums, but we're also going to need to go through and make sure that none of the values actually match. So I'm going to start by declaring a Boolean variable which I'll call is diverse, and I'm going to assign it true, because we're going to assume it's true unless we find a counterexample, unless we find a pair that works. And then we're going to have to go through and get our row sum. So I'm going to have int array totals gets row sums for array2d. And then I want to go through this loop, but keep in mind, I need to check box 0 with every box. I'm going to need to check box 1 with every box. I'm going to need to check box 2 with every box. So a nested loop is probably going to be best for us. So I'm going to say for int I gets 0, I is less than array2d dot length I++, but keep in mind that row 0 and row 0 should have the same value. So I'm going to, in my next iteration here for my next loop, I'm going to say j gets I plus 1, and then j has to be less than array2d dot length and j++. So now what I'm going to do is check total sub I and total sub j and make sure that they're distinct. If totals sub I is equal to totals sub j, then I'm going to say isDiv gets false. In other words, I found my counterexample, and that's the value that I'm going to return. No part of this loop is ever going to change it back to true. So after this nested loop, I'm going to go ahead and return isDiv. So that takes care of my issue here. I'm starting by assuming it's true, and of course this row here is optional. I don't have to declare this value. What I could do here is I could just say return false. Basically, if I find something that doesn't work, return false, and then down here I could say or return true. Either one of those will work here. Both of those are fine. The question is, I personally like to, if I have to return an item, make sure that I declare an item and make sure I return that item. But because we're talking about Booleans, it's going to be very simple to just kind of stop what we're doing and return false at that particular point. And then just return true if we successfully make it through the nested loops. Because if we've made it through the nested loops, there's no repetitions. So looking at the points here, I'm looking at us probably getting 1 point for getting the row sums, getting the totals through that. And this would be the point that we would lose if we did not call row sums as directed. We're going to have to, we'll probably get a point if we return false if a collision happens, and a point if we return true if a collision doesn't happen, as long as we have successfully gone through all of the elements. So I'm looking at a point for actually calling on row sums, a point for making sure that you successfully iterate through all the elements, a point for returning false if you don't succeed, and a point for returning true if everything works out beautifully. So 4 points on this. So for the breakdown on problem 1, I'm looking at a 2, 3, 4 breakdown for the points on there. And again, I'm not an AP grader right now. I don't know what those points are going to be. All I know is what they have given points for in the past, and that's what I'm basing this prediction on. So that's question 1, very straightforward, dealing with arrays. Question 2 is actually writing a class. And we haven't had to write a class under this new AP system before, just because we've been dealing in the context of Grid World for our prior AP exams. This one's a little bit different. So we've got this guessing game. So we've got a guessing game which a player tries to guess a hidden word, and the hidden word contains only capital letters and a length known to the player. That's kind of important. We're going to need to know that. And I'll talk about why in just a few minutes. A guess contains only capital letters and has the same length as the hidden word. Basically, we're playing almost like a mastermind type game, where if we get a perfect match in a perfect spot, we're just going to say that's the letter. If that letter shows up not in this position but in some other position, we're going to put a plus. And if it's not in the word at all, then we kind of just give them a big And so the idea is that we could construct an object of type hidden word, and they'll use the getHint method to see if the values are true or false, and we're going to be returning a string each time this method is called. This getHint is actually going to be the bulk of what we're going to write in this program, but we still have to get the structure of the class done. And that's probably the hardest thing to just go ahead and get started. So we'll go ahead and talk through this real quick. So I want to create a class. So I'm going to just do public class of hidden word. So then I need to think, okay, what does a class have? A class has a target word that we have to try and guess. So this is going to be private string target. And we're going to have to kind of specify that in the constructor for this object. So our constructor is going to be public hidden word. And this is going to be passed to us as a parameter, so we're going to have string new target. And then in here, we're just going to initialize our variable. So we're going to say target gets new target. So very straightforward, and this is the easy part of the class. And for what I'm looking at here, I'm probably looking at 1 point for a class declaration, 1 point for a private state variable, and 1 point for successful writing this constructor. The hard part is actually going to be this get hint method, making sure that we do everything that we're supposed to do. And I'm just going to put little marks over here. We need to make sure that we put a star if nothing matches. We need to make sure that we put a plus if we're the right letter and the wrong spot. And we're going to need to make sure that we actually put the correct letter if it's the right letter, right spot. So we're going to continue this class over here. This is going to be our public string getHint of type, so we're going to have our string guess here. And then what we're going to do is we're going to go through our target and see which elements of guess match our target. So we're going to go ahead and set up some type of return string here. So I'm going to say string ret, and it's going to be just a string of length 0. And then I want to go through my target. So for int I gets 0, I is less than target.length, I plus plus. And then in here, I'm going to have some conditional statements. And the first thing I want to check is this state here, if I have the right letter in the right spot. So I'm going to need to take a look at my particular letter in target. So I'm going to say if, and I'm going to say target dot substring starting at I and going to I plus 1, because I only want to peel one letter off of this. And charat would be okay, but charat's not in the AP subset, so I'm not going to put charat for my canonical answer. If I use charat, then I can use equals equals, but because this is a string, I have to use dot equals. And I want to know if it's equal to the corresponding element in guess. So this is going to be guess dot substring. And this is going to be at I to I plus 1, close parentheses. And if that is true, then I want to say ret gets ret plus an A, or not A, but whatever that is. Horrible, 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 horrible. So ret gets ret plus target dot substring I comma I plus 1. So this is the first thing we're going to check. Then it's else if. Now I want to check to see if this shows up anywhere in guess. So if, or actually I want to see if this particular letter in guess shows up anywhere in target. So if I reach this point, it's not that letter. So else if guess, actually no, I want, because I want to know if target has the letter. So I want to use target.index of. So target.index of. And then here I'm going to check if guess.substring at I comma I plus 1. And if this result, in other words, if the index of is greater than or equal to 0, if I get greater than or equal to 0, this shows up in the word. But because we're in the else, it's not at that particular spot. So I want to say ret gets ret plus, and I want to add the plus. So I'm going to add a plus to the string. And if I hit this else, then this else means it's not in the word. So then I want to say ret gets ret plus, and I want to put the asterisk. And so if I've gone through this for loop here, and this is the end of the for loop, then I've checked to see if they match, and I've taken care of it here on this line. I've checked to see if I've got a right letter, wrong spot situation, and that's what I've got here. And then I'm checking to see if it's anywhere else in the word. If it's not in the word at all, then I'm adding the asterisk. And then once I've reached this point, I'm ready to return ret. And that's the end of my get hint method, and that's actually the end of my class. That's all that I really need here. So we had 3 points here for the hidden word, just for setting up the class, setting up our instance variable, setting up our constructor. The other 6 points, I think, are going to come from this method here. So I'm going to have a point for the method header with the correct parameter and the correct return type. We're probably looking at another point for having a item that we return successfully of type string. We're going to have to go through each of these elements here, looking at a point to see if we actually do hit the correct letter in the correct spot, looking at a point for the letters that's the right letter in the wrong spot, and a point for, you know what, it's not in the word, and then a point for making sure this actually does correctly construct it all together. So this final point is going to be, you know, yes, this if statement works, yes, this if statement works, yes, this if statement works, and we've successfully gone through all of the elements. So this point is probably going to be successfully going through all the elements in target for that. So we're looking at 1, 2, 3, 4, 5, 6 points for this method. So we have written classes like this before, but in the past we've always written these as critters or as bugs, you know, some type of thing that we're manipulating in our grid world sense. So this is the first time in a while that we've had to write a class from scratch that just kind of performs a task. So that's question 2, halfway done. Let's move on to question 3. So on question 3, we're looking at a method that's going to deal with these sparse array elements. So with the sparse array elements, we have a lot of matrices that are zeros almost throughout, with the exception of a few elements that are non-zero. And it's going to be easier just to kind of collect these objects in some type of data structure and just call on them individually, because 90% of the time or 99% of the time the result's going to be 0. So we have these sparse array entry objects that we're going to be manipulating in our program here. They have instance variables of a row and a column and a value. We've got a constructor here as well, and then 3 simple accessors. What's important to note is that these things are immutable. We can't modify them as they've been constructed. We're going to have to create new ones if we want to make changes to them, and that's actually going to be pertinent in part B. So in part A, we need to kind of talk about the basic structure of the sparse array. So here's our sparse array. It keeps track of the number of columns and the number of rows that it has, but then it's also got this list up here of entries. They're not in any particular order, and each non-zero element in our array is one of these entries. So I've got a constructor which basically just constructs a new object, get num rows, get num columns, and then we're going to go ahead and talk about this get value at, and then later on we're going to write this remove column, which removes an entire column from our array. All right, so to the coding. Here is our example. So we've got this matrix. Keep in mind that it's all zeros with the exception of these 4 elements. So if I wanted to add an element to this, I'm basically adding something to the entries down here. If I want to get an element, what I want to do is I want to traverse this array and see if any of them match the row and column of a particular of our parameters. So if I'm looking for row 3 and column 1, I check and see, nope, nope. Yes, that works. The value is -9. But if I'm looking for 3, 3, I'm going to go nope, 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 nope. None of the elements in this list work, and so I'm going to go ahead and return 0. So that's what's really important here, is the fact that I'm going to be dealing with, I need to make sure that I return a value if it exists, or I need to return 0 if not. So I'm going to be dealing with that. So here's our get value at, and I'm given a row and I'm given a column. So what I want to do is I want to go through entries. And a for each loop is going to work wonders here. So I'm going to do for, and my type is a sparse array entry. Which I'm going to name item in entries. So now that I have item, I need to check item. So if item.get dot get row is equal to row, and item dot get call is equal to call, then this is what I want. So if this happens, if I reach this state, then I want to return an int. I want to return item dot get value. And that returns control to whatever call does. Now, if I successfully get out of this loop, then that means that item's nowhere in our list, and so here is our return 0. So I've gone through all of the entries, looking at each individual item. If the row matches and the column matches, then I go ahead and spit that value back at them in a return statement, so I stop searching the arrays list. And if I make it through this loop, then that element doesn't exist in the context of this matrix, and I just go ahead and return 0. So looking at what we've got here, I'm going to need to make sure that I have a point for successfully returning the value if it exists, a point to make sure that I go through all of the elements in entries, and a point to make sure that I actually return 0 in the context where it doesn't exist. So I'm looking at probably 3 points for this getValueAt method. So that's my getValueAt method. So now I want to take a look at part B. Erasing some of these smudges. So for part B, this one is actually going to remove a column from a matrix. So in other words, I'm going to pretend that this column here just doesn't exist anymore, which means this 4 has to physically be shifted over to this spot. Now keep in mind, I'm not moving the actual location. What I'm doing instead is I'm taking its column entry data and I'm switching it to a 3. So these elements that were in that column 1 are going to be gone. They're going to be removed from my list of entries. But any elements that were beyond that column, the columns 2 and more, I'm going to have to make sure that I change their elements. And I did make that mention earlier. Because these objects are immutable, I can't just change the value. I have to physically construct a new item to replace it. So I'm going to either have to remove this and add. And of course, it's important to know that the order doesn't matter. So they do mention that entries is in no particular order. So I could physically remove an object and add a new replacement object. The order doesn't matter. And so I need to keep that idea in mind. So going to our code. So here's where we're going to write our remove column. So the first thing I'm going to do is make sure that I go through my list, and there's a couple of ways that we can do this. I'm actually going to do this 2 different ways here. The first way that I'm going to do this is I know that when I'm dealing with Arraylist elements, normally when I'm dealing with an Arraylist elements where I have positions like 0, 1, 2, 3, 4, if I remove something at space 1, then this is no longer 2, this is 1. This is no longer 3, this is 2. And this is no longer 4, this is 3. So if I I++, then I may skip a box completely. So I know that when I'm dealing with these, it's often helpful to kind of go backwards through our array list. So I'm going to go ahead and do that. I'm going to say for int I gets entries dot size -1. I is going to be greater than or equal to 0, and I minus minus. I'm going to go through this list backwards to make sure that when I call on entries.remove, then I'm not going to end up skipping values when I iterate to the next element. So in here, what I'm going to do is I'm going to get that element out of the list. So I'm going to say sparse array entry or element entry. And I'm going to call it item gets entries dot get I. So I've got the element out, and now I need to look at this element and check its column. So if the item dot get column is equal to column, then I want to just remove it from the list. So this is going to be entries dot remove whatever is at position I. else, now I need to check to see not only is it at that column, but what if it was beyond the column. So if item.getCall is greater than column, then I need to change its column to the one before it. And probably the easiest thing to do would be to entries.set and set it with a new object. So a new object of type sparse array entry. But I want the parameters for the first two to be the same. So I want it to be item.getRow. And the column's going to be one less, so it's going to be call minus 1. And I can use call minus 1 because it's the column that we have up here. And then item.getEntry, or getValue. So what I've done here is I've removed it if its column matches exactly. But if its column is beyond the column, then I went ahead and created a new object with the same parameters for the row and the getValue, and a modified parameter for the column, so it's moved to the left. And then I've set that element. So I've replaced the element in entries with a new element. And that should be enough. So looking at this, remember that we have 6 points left for this. So we're going to need to make sure that we have 1 point for going through all of the elements in particular, 1 point for getting a particular element, 1 point for checking and removing if its column matches, 1 point for creating a new object and replacing it if its column is more than 1, and 1 point to make sure that we do it successfully for all of these elements. Now, I've done this with just taking the existing list and making modifications to it. There is another way that we can do this. And the other way we can do this is by using a temporary array list and then setting entries equal to that temporary array list. So I could have something where I have a list of type sparse array entries. Which I'll call temp, which is going to get a new array list of type sparse array entries. And then what I'll do is I'll go through my entries list, and if the elements need to be kept, I'm going to put them in temp, and just at the very end, just reassign entries gets temp. So I'll use temp to kind of hold all my good stuff and then just reassign at the very end. So I still need to go through my loop. So for int I gets 0, I is less than entries.size, I++. Now in this case, I'm going forward with my iteration because I'm never actually changing entries. I'm never actually removing items from entries. So the fact that I'm starting at the beginning, because nothing's being removed, I'll hit every item in this list. So that's important to know. So what I'm going to do now is I'm going to get that particular item. So I'm going to say sparse array entry, calling it item, gets, and this is going to be entries.get I. And then I need to know if I'm going to add it. So if item.getCall is greater than, just strictly greater than call, then I need to modify it. So I want to do temp.add a new sparse array entry with the parameters the same row as item. And then the column's going to have to be whatever the get column was minus 1. So this is going to be item.getColumn minus 1. And then item.getValue. So this is going to create a new object with this particular data. And then down here I'll say if item.getCall is less than call, then I just want to add the item to it. So this would be temp.add item. And that should do it. Because if it's equal to call, if I actually hit column, then I don't want to add it to my temporary array. I only want to add it if it's before, in which case I'm going to add an unchanged version, or if it's after, in which case I'm going to have to modify it and then add it to my list. So again, looking at the points here, I'm looking at a point possibly to to create a new list and reassign at the end. Point to make sure that you're actually checking the ones that are greater than and creating a new object. A point check to see if you're checking the ones before than and actually adding an unchanged item, and then one final point for making sure you hit all the items in your original entry. So still 6 points on this, just slightly different assignment here. So there's two different ways we can do this, and I think both of them are equally as valid. One gets a little bit more reinforcement of what we're doing with the array list, and the other one's just manipulating an existing array list. All right, so on to problem 4. So with problem 4, we're dealing with an interface, and we haven't seen much on interfaces in programs we've written in the past. So we're definitely going to have to take a look at what's going on here, because this is kind of interesting. So we have this interface called number group, and it has a method called contains that we need to make sure that we reflect. Contains is important because it's going to return either true or false, and its parameter is going to be a value of type int. So we're going to have to write the interface. Remember that an interface looks very similar to a class. As a matter of fact, it's very similar to an abstract class in that our method header is not going to have code because we don't know how to determine if it contains something. Our method header is just going to have the header with a semicolon after it. So for our interface, we're going to have public interface number group. And then inside here, it's just going to be one line of code. We're going to have public boolean contains with one parameter int value. And a semicolon at the end because this is going to be an abstract method that we're talking about. This is going to have to be implemented by any class that implements the interface number group. And this is probably 2 points here. So a point for declaring our interface and a point for writing our abstract method header. Which leads us to part B, where we're actually going to implement this contains. So if we're implementing contains, then we're going to kind of make sure that we have to write that method. So here we're writing a range class, and this range class is going to implement our interface that we just wrote. So we're going to have public class range implements number group. Now I'm looking at this and I'm noticing that a range has a low value and a high value that are set by the constructor. And I don't see anything in this paragraph that says that they're going to change, so I'm not going to create a accessor or a modifier for these values. But I do need to have instance variables, so I'm going to have private int low and high. And then I'm going to need a constructor, because obviously the constructor talks about these. So public range, and we're going to have int low and int high. Excuse me, no, do not put semicolon there. That is a bad thing to do. So inside my constructor, I'm just going to say that low gets low and high gets high. So just setting up my constructor there. So now I need to write a contains method. So public boolean contains, and I'm going to have some int value that we're going to have to make sure that we contain. Now this time I don't get to leave it as an abstract. I actually have to write the code for this, and I want to return if the value that we're checking, if this number falls in this range. In other words, is it less than or equal, is it greater than or equal to the low, is it less than or equal to the high? So I'm going to return value is greater than or equal to low, and value is less than or equal to high. Again, using the low and high instance variables that I had here, making sure not to say LOW the way I did for my parameter for my constructor. So we're probably looking at about 4 points for this. 1 point for the class header, including the implements. That's going to be the most important part there. 1 point to make sure that we have private instance variables. Public instance variables just are a no-no. 1 point for a constructor that sets both of our instance variables using the parameters listed, and then 1 point for correctly following the implementation of number group. In other words, writing a method called contains that returns a Boolean with a parameter of integer. So 4 points looking at for this free response question. And on to our last part. So part C of number 4. So scrolling down. So we have this multiple groups, which is going to call upon an array list of number group objects. And we're going to get each of these number group objects out. We're going to ask if they contain a particular value, and it's going to return true if it's contained in one or more of these. So in other words, we're kind of assuming it's false unless one of them comes up true. And that's going to be important to think about when we're going through this. So in this particular example, if it contains a 2, 2 is not in the range of 5 to 8, 2 is not in the range 10 through 12, but 2 is in the range of 1 through 6, so we get a true out of it. If I check 9, it's not in this 5 to 8 range, it's not in the 10 to 12 range, it's not in the 1 to 6 range, so I'm going to say false. If I'm looking at 6, it is in this 5 to 8 range, so I don't need to check any of the other ranges, it's true. And so the idea is that I'm going to go through this list, and as soon as I find one that works, I'm going to return true, and if I find one that doesn't work, then I'm going to return false. So here's our contains method that we're writing for this class, and so what we're going to do is go through each of the elements in that group list. So in our code, I'm going to go ahead and say Boolean return gets false, because false is kind of my default state. I'm assuming I'm not going to find anything that matches, and only if I find something that matches, then go ahead and return true. And I'm going to go through each of those number groups. So and I'm going to have number group G in group list. So I'm using a for each loop, and all I want to know is if G dot contains val, or num I should say, then my return value is going to be set to true. And then I will just return ret when I'm done with that. Now the thing is, because these are all number groups, I know that every number group has a method called contains that has a number integer as a parameter. And again, I'm doing what I usually do. I know that I'm going to be returning a Boolean, so I declare a Boolean and I make sure that I return it. A lot of people will just go ahead and do it this way. They'll just say return true and then return false and kind of get rid of that line, and that's perfectly acceptable. Just having the for loop, the if loop, and then 2 return statements, that's going to work fine. So probably looking at this for our remaining 3 points, 1 point looking at going through every element of the group list, 1 point for successfully calling on contains if it does contain, and 1 point for returning false if it's nowhere to be found in our loop. So, looking at this year's questions, I thought all of them were very approachable. I know that the interfaces may have been a little bit of a twist, but I thought it was very straightforward with what it asked. And if you've written a couple of interfaces, or if you've looked at the interfaces we've talked about in this class, such as our compare to method that we wrote for our fraction class, or the implementation of other things we did with our 11s, I think those are wonderful things to look at. Everything here seemed pretty straightforward. Again, I am not an AP reader, so the points that I'm putting on here are the points that I think based on what I've seen from previous release tests, and of course they may change. But I'm just kind of putting them out there as a guide. Can't wait to go over these with my students on Monday, and I hope you found this video helpful. So once again, this is Mr. Potter. Thank you for watching. Have a great day.